Good afternoon. Thank you for being with us today. It's great to see all of you online and on site. Today, we are happy to welcome Logitech to our Get to Know Your Industry Partner seminar series. As you know, it's a new seminar series put in place with the intention to promote the exchange between labs, being active intelligent systems, and representatives from the industry. Today, we're delighted to have Jean-Michel Chardon, the head of AI at the CTO office of Logitech with us. He brought along several colleagues from engineering, embedded software, and human interface technologies. To give you an idea of what to expect, the seminar will last approximately 1 hour, with Logitech speaking for 40 to 45 minutes. We will then have time for questions, so please feel free to put your questions in the chat. We'll also have the opportunity to unmute yourself at the end if you want to ask your question directly. Before we dive into the presentation, I would like to thank Jean-Michel and all his colleagues for being with us today, and the entire CIS team for making the event happen again. Jean-Michel, the floor is all yours.
Merci, Yann. Hello, everyone. Thank you for having us today. I'm Jean-Michel, and I've come along with three of my colleagues. I'm going to introduce you in a while Maxime, who is the head of R&D for our largest business group. I brought along two of our experts in embedded systems and human interface technologies. What we wanted to do today is to give you a quick overview of who we are, in case you don't know, but more importantly, to give us a sense of what technology means to us. Technology that goes into our products, everyday products that you hopefully know. The kind of technology domains we explore in the technology office, and we'll be brief on this. We'll put the accent or the focus in the end on three core technology challenges that the team wanted to share with the forum today. So Logitech, just to remind ourselves, it's the name of the company, but Logitech is only one of 7 brands that today we operate under. We have a number of brands in gaming, music, streaming. You might be aware or not that the Streamlabs service is part of the Logitech family. What all these have in common, at least for us, is the means to bring the tools, the capabilities to every one of us to fulfill, unleash our potential each and every day, whether it's at work, at play, in terms of education, entertainment, creativity, and the likes. So that's what animates us along the way. We like to think of ourselves as a design company. Yes, we're good engineers, we make use of technology, but we package it in a way that it's approachable and usable by many. And that requires us to be very clearly focused on the users, their needs, and the meaningful challenges that we're here to solve for them. Some of the trends that inform our activities today, you're probably familiar with the rise of esports, the professionalization, if you want, of video gaming and big challenges, big leagues and the likes. That means there's a lot to bring to this industry. We need to think of it that way in terms of not only gear, but you will come to hear maybe over time, but there are services that are being offered now to not only athletes, but their managers and their coaches, for example. Video, the way we use it today, is obviously everywhere for home, communication, work, obviously. COVID has only accelerated a trend that was already in motion, where we are looking to work everywhere from the office, outside of the office, on the go. And that has also greatly informed our current line of PC peripherals. And finally, that I hope is something that you're familiar with, but that the trend of streaming, whether it's streaming live content on Twitch and the likes, or creating your recorded content that you put up on YouTube, we're here with all the gear and services to help you create the most engaging content, whether it's lights, cameras, speakers, microphones, or even the Streamlabs service, which, just for a minute, Streamlabs service allows you to create live, real-time live content, blending your screen, multiple cameras, overlays. It allows you to interact with your audience, whatever the destination may be, whether it's Facebook Live, YouTube Live, or Twitch, all of them at the same time, by the way. It also works as a recipient for donations from your audience. So Logitech, quickly as a company, we turned just 40 a month ago, if I'm not mistaken. We're about 9,000 employees around the world. We move more than 3 million products a week. I think we need to update that number because last year I've seen a lot of growth. I'm sure that must have gone up. And we operate in more than 100 countries around the world. So it's not only a design company blending technologies into consumer product, but it's a huge sourcing and distribution machine that that a lot of companies envy us for. In terms of footprint, we are here in Lausanne, the headquarters of the company, but we have, I think, a dozen R&D sites around the world, from the West Coast in the US to Ireland to Asia, Southeast Asia, for example. But here in Lausanne, we've been on the park now since the very beginning of the Park, if I'm not mistaken. We were the first tenants. We're in Building K. We use the whole building. There's more than 400 of us now on site. And the beauty of it is that we have a cross representation of all the different functions, departments of a global company like Logitech. So there's more than 100 engineers, there's 3 dozen designers, there's business management for sales and marketing, as well as for our largest business unit, for example. I'll come back to it, but we also host a large number of EPFL interns, whether it's their usual internship or their master thesis. And over the years, we've welcomed more than 500 of us, not only in Lausanne, but in other locations as well. There's a big population of EPFL alumni. Most of us are either from EPFL or from the HS system, if I'm not mistaken. And finally, it's a very international company with more than 30 nationalities represented on site. I won't take too much time, but there's a number of actual initiatives that you might be interested in knowing about Logitech. It may not be the time today to discuss our attention, let's say, or actually major investments in our sustainability. We can clearly work or talk. You should actually, I invite you to go on our website and look up, there's at least 3-4 pages on sustainability and all the actions we put in place to beat the Paris Accord. It's fairly amazing what has done. There's a lot of thought leadership that went into creating some, I'm pointing at the screen here, apologize, but labels on the carbon footprint of our devices on all packaging. So bringing the industry to follow us in this endeavor in making the planet a better one. In terms of culture and diversity, we are always eager to diversify further. I talked about 30 nationalities. We're also looking at age and background and genders as well. We wish there were more female engineers or scientists. So anything we can do to help with this, we'd be happy to contribute. Quickly on the internship program, something that started 19 years ago, when we were in the US, actually, a couple of us put that into place. And since then, we welcomed a great number of interns, about 20 per semester. And they're split between R&D, Maxime's organization, and the CTO office, the one I belong to. We welcome students from all faculties. ENAC, actually, we haven't seen too many folks yet, but we love people from Sciences de Base, Sciences de la Vie. There's a lot of work, believe it or not, that you can do with us. We offer a number of positions here, but we also had times had students go to Ireland in Cork, or Innovation and Mechanical Engineering Competency Center. I can speak for my team in AI in particular. The kind of research that we do is top notch, I like to think. We've been awarded a number of publications for the last 3 years. There's about 3-4 per year. And they go to big speech conferencing or digital signal processing conferences or journals. Typical journey of a student coming to us, I like to think that they come for an 6-month internship. They love us so much that they carry over and do their master thesis with us. And if we like them so much, we invite them to stay for another year. And sometimes they stay forever. So the focus is pretty broad. And actually, I wish we could show you a little bit more of what's happening in the building, but it's hard to believe that in devices like this, the amount of engineering or science that goes into designing but qualifying the product is pretty rich. And a lot of the domains we're exploring go beyond just the traditional engineering sciences to tap into neurosciences, data analytics, and the like. So I'll give you a little bit of an insight into that when I come to speak about the techno domains I explore. I think, Maxime, it's up to you. Tell us about innovation in techno.
Voila, thanks for the introduction, Jean-Michel. So I will talk a little about, first, hi everyone, I'm Maxime. I'm in charge of the big R&D team. Is around 500 people worldwide, so a big team in Taiwan, in China, in India, some people in US, but also a very big team here in Switzerland. And what we do, of course, is research and development. So we are working on technologies that will go into a product in the 3-4 years. So what is important is, often I have to explain to people, yes, exactly as Jean-Michel said, a mouse, keyboard, they're not as simple as we think. And in fact, a lot of our success rely on the many technology we are able to bring. This is how we make a difference with the competition. And let's face it, we have very strong competition from Asia, from US, but we can still have an amazing market share, 60-70% in mice. We are #1 in gaming mice, #1 in gaming keyboard. just because we bring things that are really differentiated, that are better than what the competition can do. And you do this with, of course, an amazing team, an amazing engineering team, great design, great marketing, but most of all, the right mix of technology that people like. Oops. Well, so for example, I'll just take one example here. We work with a partner in Switzerland, and we had, as I said, the mouse, those three things, it clicks, it scrolls, it tracks. And years ago, we did a game with local partners. We did a fantastic sensor that can work on glass. Then the next thing we wanted to reinvent was the scrolling. And I know scrolling seems a simple thing, but in fact, if you bring in technology, if you find the right level of partner, if you start working with magnets, you can develop some very, very interesting mechanisms, like the one that goes into all our MX mice in MX Master and MX Anywhere mouse, which is based on a magnetical system. We used to have a very complex mechanical system before. Now, thanks with some partnership here, we were able to design a fully integrated magnetic system that works amazingly well, allows you to enable or disable the ratchet. And again, you need to think that when you bring in technologies, of course, there is first the prototype, which is the phase that goes really fast. But remember that whatever we do, we have to make millions of them. They have to be produced in factories in China, in Vietnam, or time to time so closer, where the temperature might go from 0 degree to 40 degrees because there's no cooling or heating in the factory. You have all the tolerancing. And I'm a former EPFL engineer, EL92. And so yes, it was a while ago. But by the way, it's always nice to come back here. But there is one thing you learn after, is really when you industrialize. In fact, there is huge work you have to do. And that's also part of the technology development, because having a beautiful technology in the lab is one thing, but making millions of them, amplifying it, making it at a cost that's reasonable, that everyone can use, that is also simple to use. That's also a big step. Then if we talk about gaming, I have a little video here that I will start. So,
latency, connectivity, power, weight. With all the challenges wireless hardware has to overcome, it's reasonable to ask, why bother? To me, it's simple: unrestricted motion. Our team took a firm stance that we just had to erase the technical limitations before wireless could truly be worthy of gamers' undivided attention. Our first breakthrough was an architecture we called Lightspeed. It was designed to address two of the biggest issues with wireless: connectivity and latency.
We improved it until we were perfect. We can emulate noise in our labs and put it at the maximum, even higher than in the real world, to make sure that we are still at 1 millisecond in this special environment.
At the same time, we started exploring the issue of power consumption, kicking off what might have been our most ambitious project to date, and that was the invention of PowerPlay, a wireless charging system. It delivers infinite power through the mouse pad itself. So now, the next step in our journey takes us to the heart of the mouse.
BMW 3366 was a significant milestone. We still wanted to raise the bar even higher.
We built Hero from the ground up to challenge the relationship between power consumption and performance.
Your input signal has to be the best possible quality, because everything you build relies on this front-end signal. First, you have to look at the single pixel, and then once you have a perfect single pixel architecture, then you multiply it and you build your matrix, and this becomes your front-end. The way Hero handles frame rate is pretty different from usual cordless capable sensor. We have the fastest frame rate sensor, and it slips in between frames. The goal was to make top performance and push battery life. When Hero is operating, we are using 10 times less power with 3366. It's crazy.
Since the very beginning, our goal was to unlock the potential of wireless, put it in the hands of gamers at all levels. With Hero, we're elevating performance, not just beyond the limitations of wired mice, but beyond the current capabilities of all gaming mice. The wireless future of gaming, it's here now.
Voilà. So as you see, a lot of innovation, many of them, we talk about the Hero sensor, again, done with a partner in Switzerland. So this is absolutely key because we used to be, let's face it, not in a very good position in gaming in 2012. And now we are a leader everywhere because we bring technology, we bring innovation. And so this is key. And now, of course, the big question is, what are we going to have in 3, 4, 5 years? So as you see, Lightspeed, Hero, Power Play. So to summarize, you know, I just give some example of the technology that really came here from the teams here. Some of them we work on for 3, 4 years on them. Not only the invention phase, maybe lasted 1 year or even more, but then the full industrialization phase. Because once we release a product, it has to be flawless. It has to work in any condition and be produced in millions and millions of units. And here you see all the example of those technology we have done. One, in fact, I just added the fusion engine, which is something we co-developed 10 years ago with EPFL. With the lab, we were able to mix 2 sensors, accelerometers, gyros, and the traditional sensor to make, at the time, the mouse that was the fastest mouse ever. Basically, your arm would detach before you would reach the top speed of the mouse. So this is the kind of partnership that really allow us to be at the top, to be the best compared to all the other people in those space, and they really make a difference, you know, in the quality of our product and, of course, the number we sell at the end. So voilà, that's a little on what we do here, the collaboration we have with local partners, with EPFL. Now let's take a little about the future and some of the potential collaboration we can have in the future with you. Thanks for your time. Jean-Michel?
Yeah, back to me. Thank you, Maxime. So before we come back to R&D and some of the challenges that the team wanted to submit to this audience, I thought it might be helpful or useful to share a little bit the technology domains we're exploring here in Lausanne. You might have seen us release a number of products related to AR, VR, and precision control in 6 degrees of freedom. This has been used by early adopters or integrated into digital production pipelines like animation studios or automotive industry. But what goes behind it is a lot of signal processing, sensor fusions again. And what we see is a convergence of different technologies on fewer platforms, being embedded platforms or software platforms like OpenXR. So this is work currently ongoing. Let me go to the next one. Hearable. So I was talking about AR/VR, so augmenting vision. What about augmenting hearing? So we have here in Lausanne, again, activities in packing as much intelligence as possible into what is today the smallest, most compact volume we have to deal with in terms of energy density, but computing power. The video I've put it here is an example of material sciences that we apply to customize or allow end users to personalize, customize the shape, the fit, the comfort of their earbuds. That's also the kind of technologies that we're developing here. Now, closer to what my team does in the AI team, we have 3 domains of activity. One of them relates to voice, not so much about figuring out how to understand, how to enable the machine to understand what an end user says, but it's about how they say it and the levels of information that it can actually carry. We've done a lot of work in measuring acoustics of the room to start with, but also to figure out the quality or the intelligibility of the speech, how to measure those in an objective manner, something that is not yet a common practice, but also to find ways to enhance speech so that in a communication scenario like now, whatever the acoustics, whatever the ambient noise, you're going to hear me as loud and clear as possible. So a lot of machine learning is being developed, made its way into some of our high-end enterprise solutions, but now we have the challenge to pack some of that intelligence into the tiny earbuds that I showed you in the previous slide. The next one pertains to volumetric video. We're currently using a 2D camera on a 2D screen, yet the world is made out of 3D. So we're trying to understand what are the different techniques to capture the highest quality information, depth information, in order to create ultimately not a standard imaging pipeline as your webcam, but full 3D rendering solution. We've been partnering with startups from in the area like Inverse, and this is, for example, the plugin we built for the Streamlabs service I was telling you about earlier. So again, from semiconductor to signal processing to any form of acceleration of machine learning models is of a concern here. The next topic briefly I wanted to touch on is more generically what we call human state sensing. So starting with the brains or the brain activity, we're trying to capture the information, the biosignals that inform the system in guessing what is the current state, cognitive state or affective state of the user. That has applications in many domains, professional esports again, but education or communication or productivity, I should say, for example. So we have done work in dry electrode materials, for example. We've developed our own data acquisition pipeline, combining, fusing different types of sensors. We have clinical study going on right now to identify neuromarkers of attention, for example. And we've done for a long time now, we've studied different techniques to capture heart rate variability, for example, or eye tracking, gaze blinking, saccades, and so on. And the next frontier for me will be to not just measure, but also stimulate the activities of the nervous system. Now, I will invite, I think it's Laurent first. So Laurent is going to share with you the first techno challenge that he would like to submit to this audience. Afterwards, it will be Nicolas presenting the last two challenges. Thanks.
Hi, everyone. My name is Laurent Gillet. I'm head of embedded software in Logitech for all keyboards, mice, presenters, gaming wheels. And today I will present you a challenge we have and something we want to make evolve. It's linked to the connectivity, and it's what we call wireless freedom. Wireless freedom is today we are used to remove wires everywhere. When was the last time you have RG45 plugged into your computer to have data going to your computer? Everyone today is using Wi-Fi, or almost everyone is using Wi-Fi. That's the same for the Hearables. When you are listening to music, then you don't get wires anymore. You have something wireless. This wireless freedom, in this context, removing cables can really help to give you more freedom to move. And that's something people are used to. And once you try it, you want to adapt it, and you don't want to go back and switch back to the cables. And here, the challenge I have for you is we want to move forward and to push further the limits. And still, while we are pushing the limits, we want to be as fast as corded, as performant as corded, as reliable as corded, especially in crowded environment. Crowded environment, you could have it when you are doing a line party, or when you are giving lessons with a full of students, when you have the headset, you have a mouse, you have a keyboard, you have a phone, you have a lot of things which actually congest the communication, and you can begin to perceive some latency, some lags, and finally it's not usable. And here the constraint, the challenge is, what can we do? How can we achieve high performance? When we are using a cable, we are exchanging 1,000 information per second. Today we have a proprietary protocol that goes up to 1,000 report per second, exchange per second. But within a crowded environment, it's like on a road, when you have a lot of cars in a road, you are slowed down. So how can we do it better? How can we make sure it's scalable and also sustainable? By sustainable, we need to have something which consumes less power as possible in order to have tiny battery and to reduce the environmental footprint. So here, I foresee three main directions. The first is to sustain and to optimize what we already have today. Like, do we have a strategy to limit or to avoid congestion? Can we rely on what we've learned on the INAC, for example, on a road to avoid traffic jams? Can we replicate what we have learned here and to apply it to radio frequencies? Can we evolve what exists today? Can we define a new RF protocol, a new radio frequency protocol? Today, we are leveraging a lot of Bluetooth, but Bluetooth is used to convey a lot of data over the air. We don't need to convey so much data with our devices. And we don't have today a protocol, RF protocol, dedicated to convey few information, but at a high frequency. Can we also leverage other available RF frequencies that are not used today? Last but not least, can we see even further? Radio frequencies is good, it's what we are using, but can we see other stuff like only the radio frequencies we used to do, but going, why not to using light or to using other method in order to convey data without wires? That's the three main topics I foresee: sustain what exists, evolve, or really reinvent the way to communicate and to exchange data. That's for the project I like to share with you. That's something we are really working on a day-to-day basis. We have a team dedicated to work on the protocols and making sure that whenever you are using our product, you don't notice any lag, any latency, And as long as you don't notice it's working, it means that we are doing a great job. So we are continuing and pursuing that way. I give to Nicolas the rest of the presentation.
Hello, I'm Nicolas, and I'm in charge of the innovation and technology for everything related to human-machine interface. So let's first start to discuss about gaming and especially driving simulation. So Logitech is well known for gaming-related peripherals, and very strong, is leading in almost every category. And this is true also for driving simulation peripherals, so meaning driving wheels, driving pedals. And if there's one domain where the gap between real world and this concept of digital twin is shrinking every year, is this driving simulation. We're getting very close to what you have in real life when you do racing. Yet the immersion and the performance and your perception is not exactly what you feel in a real car. So there's lots of things we want to develop to improve this perception. About a year ago, we introduced what we call True Force, which is a fast way to let games control the force feedback of a wheel. So control the torque of the motor at high frequency, so typically 1 kilohertz or over. So the game can control the feeling that the end user is getting. And we want to improve that by having better motors. So once you want to increase the torque of a motor, then if there is loss, then you get heat loss. So we want to have higher efficiency motors, better way to generate haptic feedback, force feedback, improve the quality and the fidelity of this immersion. And one of the main challenges is that you don't feel in a simulation, almost everything is focused on the vision system. So you're missing lots of things that you get in real life. Typically G-forces, the acceleration, deceleration you get when you turn or when you brake. So we want to introduce this G-force cueing, how to render that through the vestibular or proprioceptive system by stimulating those systems, ways to feel the speed and the perception other than just with the vision system. Question on why in gaming simulation, even very high-end in Formula One simulator, they don't get 3D screen, they don't get 3D perception. So what's the quality we need so that this technology can come into simulators? And we want to improve also everything related to the pedals, how you brake, and braking in race driving is based on muscle memory of this brake, the force you apply on this brake pedal. So how we can measure force in a more precise way, better way, more repetitive way. So typically that's what we have currently. There's new wheels in development, so we try to always improve the quality of this human interface. There's a short video also. So any technology that can improve this interface between the user and the machine is interesting for us. Then another domain that is really challenging is what we call digital accessibility. So at Logitech, one of our value is to let anyone connect to the digital world. We're at the edge of this, the heart of this connection between human and machine. We're defining this interface. And if you get someone with impairment that generate a disability, so a lack of ability to perform a certain task, especially in the digital world where you need to be connected to the internet through your phone, through a tablet, through a computer, we want to ease and then reduce this this lack of ability to perform certain tasks. So we want to let people with perceptual, with motor, with cognitive impairment access this digital world through some solution, whether it's software, hardware, combination of both. And to do that, we define certain design constraints that we want to be required for those type of solution. So that this solution, whether it's a product or a service, it needs to be adapted to an individual person with his own specificities, but also it needs to be made for all, not specifically for people with disability, because otherwise it creates stigma and people don't want to buy this type of product. This is too much stigmatizing. And it should cover lots of variety of problems that this user can face, and also let them be independent, not rely on someone else to do a specific task. And by task, at this stage, we're focusing on two main things that we know well at Logitech. Is what we call cursor control or navigation, how we move the cursor on the screen. And the other thing is everything related to text input. So text input, normally on a computer, you do it with a keyboard. On the smartphone, you're getting more and more voice input, voice dictation. And we want to investigate on all those new solutions to input text. So, and if you see the landscape of people with disabilities, there are many different types. It can be physical, developmental, it can be sensorial, it can be cognitive. Just on the sensorial, it can be related to touch, to ability to see, to hear, to speak. So it's difficult to find one solution that covers the entire space. So trying to focus more on the task that the user are trying to do and see how we can ease for a large portion of people the way to do this task. And that's the example of things we're doing. So in gaming, we've been doing a collaboration with Microsoft on the Xbox gamepad that is more adapted to people with physical disabilities, where we've been launching in China a solution for voice dictation. So when you're trying to enter Asian character with a keyboard, it's a long task. So that with voice, you're much faster. We're trying to understand the UI of the application that you're using on your computer, try to semantify, destructurize this UI, understand what is the task you're doing right now. And once you do that, you can simplify the UI. And just instead of letting 30 hundreds of buttons that the user can click, just focus on the few buttons that are related to the task you're doing. We're doing quite a lot of user and design studies on how we can interact with or better design products for these specific users. Everything related to getting the posture of the person, so 3D hand posture tracking that we can do with a camera, face tracking, with high quality face tracking, you can control your cursor with your head. Everything related to the UI, adaptive or simplified UI is interesting for us. So I think that's it for me. Maybe Jean-Michel, you have a conclusion?
That's it, I think. Indeed. So that was a quick roundup of our activities in general at Logitech, here in Lausanne on campus in particular. So hopefully that has inspired some of you, maybe, to volunteer your time and your expertise in solving some of those challenges.
Thank you so much, Jean-Michel. Do we have any questions in the audience? Let me say some words of closing for this seminar. First of all, thanks, Jean-Michel, and to your colleagues for being here with us today. It was great having you. I understand we can share the video, which will allow us also to reach, after your talk, a couple of more colleagues. The questions, I think, on the wireless, I think this might ring some bells for some colleagues to be seen. The next seminar is coming up next week. We are looking forward to welcome you and Professor Herzog for the CIS Get to Know Your Neighbor seminar to learn about the work that Michael is up to. And I think he has some challenges he would like to share with our colleagues from data science and machine learning. And then on December 6th, we have Professor Pauli, who is going to share with us what he's working on currently in his lab. Thank you so much, and we are looking forward to seeing you soon again. Goodbye.